In this video, I'm going to go over a couple examples of solutions to some of your homework questions on the quadratic formula. In this question, you were given a quadratic equation, 2x squared minus 3x minus 10 equals 0, and told that it has solutions, this quadratic equation has solutions of this form, x equals capital N plus or minus square root of capital D divided by capital M. This is really just a simplified version of the quadratic formula. We want to do two things. Solve the quadratic equation and find what N and M and D represent in the solution. And second, we want to use a calculator to approximate the actual values of both solutions. So here's the solution. For the first part, solving the equation to find N, D, and M, we will use the quadratic formula, which recall was negative b plus or minus square root of b squared minus 4ac divided by 2a. We plug in a, b, and c and simplify this expression to find the values of x that will satisfy our quadratic equation. Here was the quadratic equation again. The coefficient of the x squared term is a, so a is 2. The coefficient of the x term represents b, so b would be negative 3. And the non-variable term would be c, so c would be negative 10. So we plug these into the quadratic formula here, and we get that solutions would be negative b plus or minus square root of b squared minus 4 times a times c, all divided by 2 times a. We'll simplify this expression, starting with what's in the square root here. Negative 3 squared would be 9. Negative 4 times 2 would be negative 8 times negative 10 would be positive 80. 9 plus 80 will be 89. The negative and negative 3 would be positive 3. 2 times 2 in the denominator would give us 4. Hence, ultimately we end up with 3, positive 3, plus or minus the square root of 89 divided by 4. Notice, this is the form in plus or minus square root of d over m. We have a single number here, plus or minus the square root of a single number here, divided by a single number here. So what we can see from this is that n must represent 3. N would equal 3. D must be represented by 89. So D would be 89 in this case. And M is represented by 4. So M would be 4 in this case. So we finished part A. The second part, we need to actually finish simplifying this to find the values for x that would satisfy the quadratic equation. So we have two choices with the plus minus here. We have either 3 plus square root of 89 over 4 or 3 minus square root of 89 over 4. We can use our calculator to simplify each of these. 3 plus square root of 89 divided by 4 in the calculator is approximately equal to 3.11. 3 minus square root of 89 over 4, if plugged into the calculator, should approximately be equal to negative 1.61. And if we're feeling motivated, we can check our solutions just to be sure that we did the math accurately, because with these kind of problems it's really easy to make a sign error, a computational error, and end up with a different answer. So here we go. We check these solutions by plugging them back into the equation. So here we're checking 3.11, plugging in for x and simplifying and showing that it does indeed equal 0. Plugging in negative 1.61 for x into this equation, we can simplify and show that it does equal 0. Hence, both solutions check out. The second example is a word problem. It says, the length of a rectangle is 4 inches longer than the width of the rectangle. If the area of the rectangle is 335 inches squared, we want to find the rectangle's dimensions, the length and the width of the rectangle, and round our answers to the nearest tenth of an inch. Here's the solution. Start by drawing a picture. We have a rectangle. If the width we represent with W, the length is supposed to be 4 inches longer than the width. So then the length would be the width W plus 4. So the long side is W plus 4. The short side or width is W. The area was 335 inches squared. We should already know by now that the area of a rectangle is length times width. So according to our picture, length would be W plus 4 times the width would be W. And the area we know is 335. So we have 335 equals W plus 4 times W. Area equals length times width. If we simplify by distributing the W here, we get W squared, which is W times W, and then 4W, which is 4 times W. Set this equal to 0 by subtracting 335 on both sides so that we get 0 equals W squared plus 4W minus 335. We now have a quadratic equation that we can solve using the quadratic formula. Here we have the coefficient of our W squared term is A. The coefficient of our W term would be B, so B would be 4. And our non-variable term is our C. So, plugging these into the quadratic formula, A equals 1, B equals 4, C equals negative 335, we get W, which is our variable this time, equals negative B plus or minus the square root of B squared minus 4 times A times C divided by 2 times A. Simplifying within the square root, 4 squared is 16. Negative 4 times 1 would just be negative 4. Then negative 4 times negative 335 on the calculator should give you 1,340. 1,340 plus 16 is 1,356. You can use the calculator for this part. Just divide these into the two separate solutions. Negative 4 plus square root of 1,356 divided by 2, or negative 4 minus the square root of 1,356 divided by 2. Putting these in the calculator, negative 4 plus the square root of 1,356 divided by 2 is approximately 16.4. Negative 4 minus the square root of 1,356 divided by 2 is approximately negative 20.4. We're not going to use a negative result because we're dealing with dimensions of a rectangle and it does not make sense to have a negative dimension. So we are going to use 16.4 for our W, which remember was the width. So the width would be 16.4 inches. And because the length is 4 inches longer than the width, we just have to add 4 to 16.4 to find that the length is 20.4 inches. Hence, we have our dimensions, and we can check them by multiplying and showing that they do indeed equal 335, which was the original area of the rectangle.